Next experiment is a transient response of series RLC circuit by using PSpice schematic. Take here from this P pulse per pulse input, transient response of series RLC circuit per pulse input. Okay, so place this element pulse. Okay, and then close, take resistor and take inductor also. Inductor L, enter here L, place L here. And then take C also, RLC values, place C, and then rotate this element by pressing Ctrl R, and then connect these elements. The elements are connected like this. Take one ground also, ground earth, and so this is for a series RLC circuit. So I'm changing resistance to 2 ohms. I'm changing the resistance to 2 ohms. Okay, so 50 value is called, I'm changing 50 millihenry, 50 millihenry. 50 millihenry. So we'll get a proper about millihenry mH. Save alter. And then 10 microfarads. See, take 10 microfarads. UF, 10 UF. Okay. And then so we will give the input that is called pulse input. Pulse input is first DC 0. Save alter, and then AC 0 volts. Save alter, and V1 is called, for example, minus 220. Okay, VD is called plus 220, and delay time, for example, delay time 0. Then rest time 1 ns, 1 nanosecond for generation of pulse. Fall time also 1 nanoseconds, and the pulse width 100 microseconds US, and the pulse finally pulse repetition 200 microseconds. Okay, so and also analysis also change. So instead of bias part point details, make a tick mark on transient and double click transient, and choose final time 1 milliseconds. Okay, so then close, then run. So they can label V input. This is called our V input, V in. This is the label V output. Output across the capacitor. Take the label like this, and after this, save this schematic. Okay, so I'm changing, save like this. After this, after save, run this simulation. So press, and then you will get a new window like this. So try to observe the waveform across input. This is called our V input. So our input is called a pulse waveform or scale waveform. So like this, this is our input. Our input is called scale waveform. Next, and then next, how to observe the waveform across the capacitor in nothing but V output. So like this, you will get the output across the capacitor. So here, 1 millisecond output across the capacitor, you are getting like this. So for input, and current also IL1, inductor current. So we get this type of resistance. Here time is required more. That's why it is appear like this. For example, instead of millihenry, for example, I'm taking the inductance value. Okay, inductance value microhenry. Instead of millihenry, I'm taking microhenry. Then you can easily understand the waveforms microhenry. So save all this. Okay, and then run again. And this is color. So open like this, and then from this, so we input like this scale waveform or pulse waveform, that like this pulse waveform generated. Okay, this is called pulse waveform is generated like this, and then after that, so uh, how to waveform, that means voltage across the capacitor, that is called V output. So you will get like this voltage across the capacitor. So open like this. This is called voltage across the capacitor. And then also current flowing through the inductor. Current flowing through the inductor or resistor. Both are series, na? That's why IL1. So this is called current flowing through the inductor. You will get like this. This is called current flowing through the inductor for transient response of series RL circuit, for pulse input or scare input. Okay, in this way, we have to analyze the transient response of series RLC circuit by using pulse input and also by using phase bias.